Alright, welcome. Today we are going to look at parallel and perpendicular lines, but really we are focusing on those that are parallel today. You want to be able to also write equations to describe lines that are parallel to a given line. So if you notice to the right, we have a graph, and these two lines are parallel, and they are parallel because they are drawn or graphed in the same coordinate plane, and they have no points in common. So in other words, they do not touch. Okay. So if we were to continue these lines on forever, they would never touch one another, so they're parallel. So two different non-vertical lines are parallel if and only if they have the same slope. So parallel, same slope. All different vertical lines are parallel. So if they're vertical, they're always going to be parallel because they're going straight up and down. So here we want to look at this graph and identify which lines are parallel. So here, if you look, if we're just looking at the pictures and ignoring, our blue lines are parallel to each other, and we can check that by looking at their slope. So here, this is in slope-intercept form, so the slope is 5/3. Here, their slope is 5/3. Since the slope is the same, they're parallel. Then, our red lines are not parallel to the blue lines, but they're actually parallel to each other because each of them has a slope of 1. Same slope, parallel. So now we're going to look at equations of lines to determine which ones are parallel, and we can do that without graphing just by looking at their slope. Now since 3 of these are already in slope-intercept form, so namely this one, and this one, all we have to do is look at their slope. -1/2, +1/2, and -1/2. So since the top and the bottom are both -1/2, these two are parallel. Now, our third one is not in slope-intercept form yet, so what I would do is go ahead and solve this for y to get it into slope-intercept form. So I'm going to divide both sides by 2. So now y is equal to -1/2 x minus 3. And now I can look at my slope. Well, since it has a slope of -1/2 and so does our other, that makes these two parallel as well. So now it's your turn. I want you to go ahead and look at these equations. Remember again, I would get them into slope-intercept form first, compare their slopes, and figure out which ones are parallel. So I'm going to go ahead, since none of our ones that are already written in slope-intercept form are parallel to each other, I'm going to go ahead and simplify our other ones. So here 2x plus 3y is equal to 12. I'm going to subtract 2x. So now 3y is equal to, I'm going to switch my order around just to keep it consistent. Divide everything by 3. So now y is equal to -2/3 x plus 4, because 12 divided by 3. Here's our slope. So these two are parallel. And then if I were to simplify this point slope one, I'd have y plus 1 is equal to 3x minus 9. And because we really don't need to know anything besides our slope, this one, our slope is 3, which is not the same as 2, so this one, only the two middle ones are parallel to each other. So how does this apply to what we can do in math class? Well, we can actually prove that things are parallel by comparing their slopes. So here we can confirm that JKLM is a parallelogram because opposite sides would be parallel. So what that means is I'm going to compare the slope of this line to this line and show that it's equal, and then I'm going to compare the top and the bottom to show that they're equal. Well, really, the top and the bottom are horizontal lines, so they both have a slope of 0, so that's parallel. So now I just need to look at my side lines. So I'm going to find my slope, so I'm going to do y minus y, so 3 minus -1 over -1 minus -2. Go ahead and double slash. So this becomes 4 over 1, or just 4. So now I have, on the other one, 3 minus negative 1 over 3 minus 2. Once again, double slash. So we have 4 over 1, which is just 4. These are the same slope, so it's a parallelogram. So now that we understand that same slope means parallel lines, we can actually use that information to find the equation for a line that is parallel to another one, depending on the information that we're given. So here, we want to find the equation in slope-intercept form for a line that passes through 410, and it's parallel to y equals 3x plus 8. So first, we're just going to find the slope from our line that we're parallel to, so in this case it's 3. So our m, or our slope, is equal to 3. Now we're going to write it in point-slope form, and then convert it to y equals mx plus b, or slope-intercept form. So we have y minus our y value in our ordered pair, which is 10, is equal to our slope times x minus our x value, which is 4. Now I'm going to simplify to slope-intercept form. First I'm going to distribute, so we have 3x minus 12, and I'm going to go ahead and add 10, so I solve for y. So y is equal to 3x minus 2. So this line is parallel to that line, and it goes through the point 410.